Welcome to your video on solving radical equations. We're going to start by listing off the steps, and usually steps are best worked when looking at a problem as well. But for now, let's just get the order down and then we'll talk about these as we solve. So number one, we want to isolate the radical, or to get the square root by itself. This is just like when we would solve an equation for x. If you see a plus in the equation outside the radical, you're going to have to subtract. If something in front of the radical is being multiplied, you're going to have to divide. So step one is to get the square root by itself. Once we get the radical alone, we have to cancel that out. And if you remember when we first started talking about radicals, taking the square root is the opposite of squaring something. And so when we want to get rid of the square root, we are just going to square both sides of the equation. So it's a little bit different because we're actually going to put parentheses around the entire side of the equation and then square it. Once we've done that, you are just going to solve for x. And here again, you're just using opposite operations. It should look very similar to when we solved 1- and 2-step equations at the beginning of the year. Step number 4 is a new step. This is where we have to check our answers. And I know in the past we would say, oh yeah, check your answer, plug it back in and see if it works. And sometimes you do it, most of the time you wouldn't. But here, this is a must do. If you do not check for extraneous solutions, there's a possibility that you could actually get the wrong answer. So what an extraneous solution is, it's an answer that works out from the squaring process, and an answer that you would get by going through solving. But when you put it back into the original equation, and that's important, it has to be the original equation, it gives you a false answer. So a perfect example would be if you had something like the square root equals -4. If we were to write that equation down, you might say, oh, if x is 16, that would work. So if I plug 16 in, and if I take the square root of 16, the square root of 16 is actually 4. And 4 does not equal -4. So that would be a not true statement, which means we could have an extraneous solution. So that's the type of work that you would see when you're checking your answers. So let's get started. And the notes here are going to go a little bit differently than they have in the past. We are going to work through the odd numbered problems with you, and then you're going to press pause and try the even numbered problems. And then when you press play again, we'll reveal the answers and you can check your work. So problem number 1, very simple, straightforward problem to begin with. We check that the square root is by itself, and it is. So we're going to jump right to step 2, which is where we square both sides of the equation. When you square a square root, that is an inverse operation, so that cancels out. And when we square the 8, we get 64. Okay, so we're actually almost done. We do have to go through the checking process, and you will have to show this on all of your assignments and assessments. We plug the 64 back into the original, so it's the square root of 64 is equal to 8. And then we just evaluate. So the square root of 64 is 8, and 8 is, of course, equal to 8. So that means we don't have to do anything at this point. We get to keep that answer of 64. So now you want to look at problem number 2. Press pause, and then once you've worked out the problem, you can press play again, and you can check your answer. Okay, so here is your check. Go through your work, check the work with ours, and then, of course, if you have any questions, you can talk to your teacher. Example 3. This one, we actually do have to go through the very first step of getting the square root by itself. So what you'll notice here is that we've got a 9 out in front of the radical, and that means that we are multiplying. So to isolate the radical, we are going to do the opposite and divide. So we get the square root of 4x equals 6. Now we're to the step where we square both sides of the equation. And we end up with 4x equals 36. Now we solve for x, and this is a simple one-step equation. We divide both sides by 4, and we discover that x is 9. Now do not move on. You do have to check your answer. We simply plug that back into the original. So we have 9 times the square root of 4 times 9 equals 54. Simplifying, we have 9 times the square root of 36. Taking the square root of 36, we know that that is 6, so it's 9 times 6 And you can see that both sides of the equation do work out to be 54. So again, we don't have to do anything. This is an answer. We just move on. So now you should press pause and you should try problem number 4. And then we will review the answer and you can check your work. So here's the work for number 4 as well as the check. Please make sure that you did your work correctly. Example number 5. If you're looking at your note sheet, you will notice that this does not look like your example number 5. We did make a change, so please cross off the problem on your sheet and copy this one down. All right, our first step is to get the square root by itself. And in this case, we have to do subtraction because the plus 1 is outside of the radical. So after subtracting 1 from both sides, we get the square root of x equals a -4. Now the radical is by itself, so we're going to square both sides. Real important thing here, that's a -4. Make sure that if you're typing that in your calculator that you put it in exactly as we have it written here. It has to be in that parentheses. When we do square a -4, we get a positive 16. Okay, again, we do have to check. So we plug in the 16, so we have the square root of 16 plus 1 equals a -3. The square root of 16 is 4. 4 plus 1 then, carry everything else down. And when you simplify that left-hand side, we get 5 equals -3, which is not true. Yes, we are very sad about that. So 5 does not equal -3, which means that x equals 16 is not a solution. So you kind of slash your solution and you change your answer and you write no solution. So that 16 was something that worked out with algebra, and that happens sometimes when you square things. But when we checked for the extraneous solution, we found that we actually had one. It was an extra solution that did not work. And so we have to change our answer to be no solution. So at this time, you should press pause and you should try problem number 6. And that is the same. You don't have to make any changes to that. All right, and here is your work. This is again a no, and so your final answer then would be to write no solution. So you cross off the 81 and then you write no solution. So you can see the importance of going through that check. It's not something that you can ignore because if it does work out to be no solution and you give a numerical answer, clearly that would be incorrect. You are now ready to begin your practice, and as always, if you have any questions, please see your teacher.